Hello, everybody. My name is Yakov Fain. Hello from New York. I'm glad to be back in Kyiv, where I come every year. I am originally from Kyiv, and I live in the US for 26 years. But I still like to come back. And today's presentation is about blockchain technology. In my opinion, it's pretty cool technology, and it's very practical. So if you are looking at the next big thing, at what's to learn next, this is something that software developer will need to know, and these people are in demand already. I work for the company called Farata Systems. It's a consultancy. I am a Java champion. Recent books of mine are not in Java, though. One of them is second edition Angular, development with TypeScript, and I like TypeScript. And the new book that is in the works for Manning as well is TypeScript Quickly. And now let's talk. I'll be talking about technology. I'll be talking about how it works under the hood, what you should know as a programmer, as a developer, not as a person who wants to get rich soon, even though it's not a bad idea. So let me go back to 1993. Actually, I am in the US from 1992. Then my wife came with my son, and we had an apartment. The area was called Troyeshchina. Do we still have this? See? And when we decided to stay in the US, my wife came back to sell the apartment. I don't know if you remember 1993. Maybe somebody wasn't even around yet. But it was tough to sell apartments. It was tons of cash. Back behind the main train station, Uritskova Street, there was many offices. And she met with that guy who was smuggling cars from Germany. And he brought tons of cash. And she was afraid to even leave. Maybe she would be killed or something. The problem was that they didn't trust each other. So there should be some middlemen, so they could deal somehow between each other. Important words here are they didn't trust each other. So you have two people, and they want to sell a house. And they need a notary, right? To put some record somewhere in a ledger. Ledger is also an important word here in blockchain technology. Ledger, a book, a gross book, where you put stuff that is happening. And what if the notary is corrupt? Notary is a third party, like a trusted person. What if he is corrupt? What if that ledger is burned on fire? So there are some issues. So the problem is that we have two parties or more than two that do not trust each other. That's why they use a third party, like central authority. And they use a ledger, registry. For example, if you want to send money somewhere, how would you do that? You can go to your bank, right, and write a check or do a transfer, but it goes through the bank. In this case, the bank is a central authority. Or if you are abroad, you can go and use MoneyGram. You can use, what else they have? Western Union, something like this. It's a third party. It's a central authority. And they will create a record over there in their database saying, yes, Yakov sent $1,000 to Mary, for example. And hopefully, we will have access to that bank, and hopefully nobody else, bad guy, will not corrupt their database. The next question is there a way to maintain this ledger ourselves? All of us, for example, let's imagine that we are a group that has different transactions, that has to do different transactions. And can we somehow have a trusted ledger? I give you something, you give something. And can we do that without a central authority? And the solution is blockchain technology. And blockchain technology can be used in many, many different areas. Originally, it was introduced back in 1991, many, many years ago, by these two gentlemen. And then, in October of 2008, Satoshi Nakamoto, nobody knows what it is, if it's a real person or if it's a group or it's a fake name, but a white paper was published under this name. And this white paper was called Bitcoin, a peer-to-peer electronic cash system. And that white paper was explaining how to use blockchain, a technology, for all these operations for peer-to-peer electronic money transfer. And Satoshi Nakamoto used cryptography. That's why there is a term, cryptocurrency. Cryptocurrency. And I want to make sure that we don't mix these two words together. Blockchain is a special decentralized technology of storing immutable data, data that is written in stone. You cannot change it. How this works, I'll explain. But that's a technology. You can use it for different domains, different tasks. Bitcoin is a concrete implementation of certain task that is using blockchain under the hood. So Bitcoin is an application, technically, that is using this technology. And now we need to talk about centralized versus decentralized processing. Centralized processing is when we have a central authority. Like I said, a bank, for example. You have a server somewhere in the bank, you have branches, node 1, node 2, node 3. These little circles on my diagram, they represent computers. When I say node, it doesn't necessarily mean one computer. It could be 2, it could be 3, it could be a little network. You go to a branch in a bank. You don't care if they have 1 computer or 2 or 3 in that branch. The main point is that they have to connect to a central server. Decentralized processing is when there is no server. And when there are multiple computers, and each of them independently can perform certain tasks. And this is exactly what is used in classical blockchain technology. Decentralized. We store records in there. If we'll go back to this notary public, there is no notary over here. Each of these nodes has complete database, which are the same. If a record needs to be inserted, a transaction needs to be inserted, we insert so-called block. And when somebody wants to insert a block with some transaction specific to a domain, this somebody will say to everybody in that peer network, guys, I need to insert a block. Let's do certain work. I'll explain you what. And everybody, let's say we are the member of the same blockchain, everybody on their machine, on their CPU, on their farms, server farms, whatever you can afford, we try to solve certain problem, mathematical problem, until we have a right to insert a block into the blockchain. But once again, no server. Each of us has the same exact database. The question is, can we trust that database? Can we trust that none of you will try to play with it or modify the data? We'll talk about it. For now, just remember, no server. Consensus. These are воры в законе. I don't know a similar term in English. So, how do they know if общак is correct? How do they know that? It's a consensus, it's an agreement. They have authority. If all of these nice gentlemen believe that everything is fine there, this is done deal. There is no records, right? No database like Oracle or Sybase. They know. Can they cheat? First of all, they don't look like they can cheat, but what do they need to do to cheat? If majority of these guys will say that I paid, say, $100,000 somewhere. If they agree, even if I didn't pay, it is considered a done deal. Why do I use this slide? Because in a blockchain, the same thing. If more than half will say, this is valid block, this is valid record, then it is valid record. And accordingly, if the blockchain is small, like this, there are chances that they can agree with each other and say, let's say that Yakov actually paid $100,000, even though he didn't. But if a blockchain has thousands and thousands of people, the chances are slim that they will agree and cheat and lie. So any blockchain is trying to bring more members. The more members are there, the more secure and trustworthy it is. So blockchain is an immutable ledger. Blocks or records are linked together. Visualize something like linked list, kind of. Not exactly, but kind of. First block, it has inside information about one or more transactions, like Bob paid Mary $2,000. Joe paid Peter $500. All these are transactions sitting inside the block. Plus, there is some additional information that is required for the block. And these blocks are linked using hash values. And we use cryptography to calculate these hash values. And multiple parties, all of us, once again, we are the same blockchain and you are nodes in this blockchain. Any of you can insert the block into this blockchain. After that, this block will be replicated. Who will be the first? Who will be the one who will insert this block? Whoever will solve a certain problem, certain math problem first. When we have enough transactions and it's time to insert a block, let's say I am the one that, let me give you another analogy. Let's say each of us is sitting in here and each of us is holding a piece of paper, blank. This is a piece of paper where we will record transactions. Let's forget about computers. And somebody is saying, Joe paid Mary $500. Each of you put a record. Joe paid Mary $500 on the piece of paper. Then the next, the next, the next. And let's say this piece of paper can hold 10 transactions, always. So whenever this piece of paper is full, 10, then it's time to insert the record into the blockchain. It's time to create a block with 10 transactions, right? So let's say I am the one who recorded the 10th transaction on my piece of paper. I shout, I scream, guys, we got 10, let's insert it. And each of you will try to solve some problem. Some of you will be first. Is it me? Maybe not. Whoever is first, they will scream, I got it, I solved it. And this is my solution. Each of you will look at the solution and see, oh, they can check easily. Yes, it is a valid solution. Then I will insert a block, and each of you will insert a block. For being the first, I will be rewarded. In case of Bitcoin, I'm going to get Bitcoin. We'll talk a little bit more about it. So blocks are chained into a blockchain. Like this is like a chain in the bicycle, right? In this case, we have 3 blocks. Now, then, let's talk about hashes. I'm sure most of you know or used hash value sometime in your work. So basically, a hash function takes the input, applies its algorithm, and produces the hash value for the input. For example, you can take a large text or a small string or a number, give it to that function, and it'll spit out a fixed length hash for whatever you gave. And this hash can be more or less secure. So when we talk about the blockchain, when we want to insert a new block, I will store in there, obviously, all transactions specific to business, but also the hash of the previous block, like a link to the previous block in the chain, and I will generate a hash to this block. And this is how these blocks are chained. Like transaction, sender, receiver, amount, this is a business specific. And there are different hash algorithms. The simple one may be not secure in that it may have so-called collisions. If more than one value can generate the same exact hash, we say it's a collision. So it's not a secure algorithm. But there are complex hash algorithms like SHA-256, for example, pretty popular. And it's collision resistant. The chances are really, really slim that more than one value will do that, will generate the same hash. I will show you some example. I'm using TypeScript as a code. For Java developers, understand TypeScript immediately, technically. I'm teaching different trainings, and I see that. So a little difference with Java. For example, in Java, you would declare the type first and then the variable name. In this case, they decided to change it, right? Next, the method signature ends with the return value. In Java, you would put it first and so on. No big deal. Java sources compile into the bytecode, but TypeScript is compiled into JavaScript. So you write in TypeScript, it generates JavaScript that runs in all browsers, new or old and everything. So that's my quick crash course on JavaScript, on TypeScript, sorry. So let's take a look at this simple hash function. Let's say I decided to write my hash function. So let's take a look. I called it hashMe. It takes a password. Let's say a password is a number. And it's supposed to return a number, calculated hash. My algorithm is way too simple. Look at this. What do? I use modular operator trying to find the remainder from division by 2, right? And I add 10 to it. Then I print a console log. It's like system out println in Java. I say, original password, you gave me this, and hashed value is whatever I calculated. And then I return it. If I will start invoking this function with arguments like 2, 4, 6, 800, on the right-hand side, look at this. I always will get 10. Agree with that? Any even number will give me 0 as a remainder, right? So 10 plus 0 is always 0. So this is kind of a stupid hash function. Obviously, nobody would use it. But at least I'm telling you that, I'm showing you the example, a function with collision, not secure. By the way, on slides, if you will get the slides, at the bottom I have the links to run this example. Let me see if I can do it, if internet works. Yes, internet works. I'm using this special tool online. It's called CodePen. In there, you can put fragments of HTML, CSS, JavaScript, and you see it at the bottom, you see the console output. See, the same function, it's already gave me. I invoked this function 4 times. See this? hashMe 2, 4, 6, 800. At the bottom, you see the output on the console. So this hash function will always produce 10, even though the values, input values are different. No good, no good. Let's talk about this one, collision-resistant hash function. They are so popular, they are everywhere. In Java, they have a function in Java security package. There are different utilities. In this example, I'm using the one on Mac. There is the one on Windows. On Mac, it's called SHA-SUM. So you can take any input. In this case, I take hello world. I am piping it into this SHA-SUM, and I'm saying I want to apply hash 256. And it will give me a hash value that looks like this. SHA-256 always return you a length of 64 hexadecimal value. you can go online, you can find hash calculators. So you enter anything, you can enter the whole poem, and it'll return you always the same fixed length, the hash value. Browser supports it. The browser has this crypto object there. The server-side Node.js also has it, so they are everywhere. And if you will calculate hash and you will decide to build your blockchain, like on this example, once again, besides having the domain-specific data, you have to have a reference to the previous block hash, right? So the very first block doesn't have anything previous, right? That's why it's called Genesis block. And look at this red arrow. It points at the previous hash is empty, there is nothing, because there is no previous block. And right above, there is hash of this block. If you take the next block, this one, we already have this block was generated, and it points at the previous block's hash values. This is E, 3B, and so on. Up above, there is some business-specific transaction, like Joe paid Mary $20, Alex paid Lou $55. Let's call it transaction. But again, realistically, you have more than one transaction per block. So that's an example. But to create a new block, you need to calculate the hash, apply this function. You need to get a link to the previous block's hash. But the thing is that you need to generate the proper hash value. Actually, let me show you. To generate just any hash value, it's very easy. And I showed you, and maybe you don't, let me show you. Let me do this. See this hello world? If I will enter this command in my computer, on my command line, it generates me hash. Will this hash be good enough for creating blocks, for inserting blocks, for representing a block in my blockchain? The answer is no, because it was so very easy for me. I generated it really fast. That's why, I'll show you in a minute, there is the commercial blockchains use something that is called proof of work. They don't want me to create any hash. They want to say, this block is good for our network only if the first 5 symbols in this hash are zeros. How do I know if they are zeros? How can we guess it? But they say, unless you will calculate somehow the hash that has 5 zeros in the beginning, we will not accept your block. So, and this is something that is known as proof of work. We'll get to this again. So, if you remember, when I said each of us is sitting with pieces of paper and we are waiting for 10 transactions, and when 10 is done, we say, go, and we try to calculate it. Somebody did it, and we need to put a stamp, right? But as opposed to regular pieces of paper with regular rubber stamp, a stamp, so to speak, is specific and it is calculated for this particular block based on its value. We take the value of all transactions. Imagine that we concatenate it into a string, all these transactions. And then we take the previous block hash, right? And then we say, let's calculate hash for this block. Boom, it gives me hash. It doesn't contain 5 zeros in the beginning. Nobody will take it. So what do? I'll try to use brute force, so to speak. I'll say, all right, I have this concatenated content of the block into a string. What if I will add 1 to it, concatenate 1, and recalculate hash? No, still no 5 0 in the beginning. 2, 3, 4, 1,000, 10,000, 20,000. My computer keeps working and working and working. Boom, at some point it gives me hash value that contains 5 zeros. That's why, if I did it sooner than any of you, I'm the winner, and I will be announced that yes, I have a right to insert the block. But technically, by providing this block, I created like a rubber stamp, but specific for this block. If I am the one who calculated this hash, in this case it's 40, it's fast, 50 is slower. Even though I'm the one, I said, guys, this is a hash value that you need. To calculate this value, it takes time. But to check that this is the right value, it's very easy. Any of you can quickly take the content of the block, string, imagine that is string, a number that I gave you, concatenate these two, and immediately you will get the result. So you guys will verify that I'm not lying. For example, say you want to add this block with this information. Number of the block is 4, June 4th, 1530. Simon refunded L $200. That's a business transaction. If I will just turn these data into a string, again, look at the black screen. Simon refunded, and then I again give it to this utility. It's going to give me some hash, which is now good. It doesn't start with 4 zeros, right? But if I will give it the same exact string, but I added at the end. I added the number, this magic number. If I will add it, it'll produce me a hash with 4 zeros in this case. Let me show it to you. How do I do this? Obviously, I did my job in the beginning, and I prepared this special number, but for now, let's do this. See, I generate a regular hash, no zeros. But look at this. Now I added to the end, I added this number. And this number, it's called nounce, N-O-N-C-E. Number that you can use only once, nounce. And this is technically your secret key. This is your unique rubber soul. So let me do this. I hit enter. Look at this. Look at this hash. It starts with 4 zeros in this case. So it's very easy to check. If some of you would calculate this number and announce it in the entire blockchain, we can easily, immediately see, yes, this is a valid one. Now let's take a look at the sample block. The sample block is this, and we have obviously data, some specific transaction. It could be an array of transaction, and we have this nonce, the number. So we calculate it, and it's a part of the block that makes the new hash. So they start with 4 zeros, for example. It also has a reference to the hash. It also has a reference to the previous block hash. So this nonce is technically a proof of work. It's a proof that yes, I did spend some CPU power on my machine or my server farm, and yes, I calculated, I solved the puzzle, the problem, and this is what the number is. And here's the code, the sample code. It's not overly complicated. I have a function generate cache. It takes the string as an input. It'll apply some function. This text encoder, it'll encode it in UTF-8. Then await is basically for asynchronous execution. And then I say crypto. Crypto is a package. Crypto is a package that calculates, that has an API to calculate different hashes. In particular, in this case, I calculate SHA-256 hash. Then again, transformation into the hash array, and hash hex is a string. So the array would look like this, and I turn it into a string that will look like this. So I'm finding a hash in this case. But again, I don't know which hash is going to be. So I will need to call this function repeatedly, providing different input. Look at this. If I want to calculate a hash that starts with 4 zeros to hello world, right? So what do? I say, I want to mine the block. By the way, to mine the block means to find this hash that will serve as a digital signature, as a rubber soul for this block. So I'm mining, I'm working, and finally I will get the result. So the function mine, what do? I have a loop, do while, right? And I keep calling this calculate hash with nonce, and I keep incrementing this nonce. I'm saying, all right, you have hello world, that's the main business information, so to speak. Now let's try to find this addition that we can concatenate at the end that will generate enough zeros in the beginning. See, in a loop, I keep calling this function, attaching this nonce, and at some point, I will get the proper hash value. And then I will print it at the bottom. Let's see it in action. I have a link somewhere there. The same exact code. Now it works. At the bottom, you will see the console, and when it's done, it will show me, I believe I put 5 zeros. In a loop, I'm trying, see it's done, or it's 4. In a loop, I invoke this function, and I check. See, I invoke this function, I check. If finally the hash starts with 40, I'm sorry, if it's not start with 40, I keep doing loop iterations. Finally, it gives me the value. See, even with 4 zeros, it took some time. If I would specify 50, it would take a lot more time. 60, I mean, forget it. So, this is the hash. Here's a use case. You know these people, right? Elections, blockchain, immutable data. If we will record voting of people in March as blocks in a blockchain, all these hash values will be calculated over here. See these? Hash value, previous hash value, and it'll be inserted. In this case, it's a block with 3 transactions, right? 3 votes, so to speak. And you cannot delete them. I mean, now think about it. If I decide, if I'm a bad guy, and I decide to update one of the blocks, see, it says Shevchuk for Vakarchuk, and I will change Vakarchuk to Poroshenko. And I will try to insert this block in my machine. Each of us has the same database. I will try to change it. The hash value will be absolutely different as soon as I touch it, right? So now what I need to do now, I need to recalculate all hashes in the chain, right? Because the hash of my block is different now. Any hash of the future blocks will not work. The links will be different. So I'm trying to do this. I announce a block which is modified, and you will reject it, of course. You will say, what are you doing? This is not right. So that's what it means that it's immutable. And now let's talk about the money. How do they get the money? All these bitcoins, for example, that everybody goes crazy about it. In the past, mining was easy, right? It's a gold mining. We understand how it works. You found gold, you got gold. And then money is a representation of gold that you have. These days you have governments, right? For example, dollars. So our government can print dollars whenever they think it's correct. So this is how they bring new currency, new bills into circulation. We understand this, right? But what about bitcoins? How do they appear? How do they appear? Because of mining. So that time that I spend to find this digital signature, this nonce, this proof of work, should be rewarded. Why? Because, once again, the more people we have in the Bitcoin, for example, blockchain, the more trustworthy the network is. So we are, as a company, we are interested in bringing more and more people. So other people can trust that this is a solid thing. So if I am the first who calculated this, who solved that problem, this math problem, I need to be rewarded, and I will be rewarded by a Bitcoin. In the beginning, people tried to get into this business with their computers. Then they started to use GPUs of their computers, which showed that they are faster to solve these math problems. Then people started to create special hardware for mining. And then people started to create farms, server farms. Like in this example, this is one of the farms in close to Seattle in the United States. They are mining bitcoins. All these are shells of computers, specialized computers for mining bitcoins. And this is probably one of the super successful farms. And they mine 7 bitcoins a day. Imagine how much money is that. 70, 80, 90, $100,000. This is what they make. Of course, they invested a lot of money into all this hardware. They need a lot of power, by the way. Why do they move into some desert area close to Seattle? Because very close there is a power plant that produces electricity. And they want to be very close so the electricity is cheap. That's why they are sitting there. So, see, out of the thin area, they generate bitcoins technically. They don't mine anything. You cannot take it in your hands. It's not gold. It's not paper dollars or anything. Just it's a reward. But people get money for this reward. Yes. Question. Well, transaction. The question was what a transaction contains. The very first block. You mean Genesis block? It just says it's Genesis block. It's nothing. And the previous block reference doesn't exist as well. So Genesis block, it doesn't matter what it has in terms of business or transaction. It's a special, unique block. The next block will already have some business transaction and a reference to the previous one. It does not matter what. No, not necessarily. The Genesis block will generate the. Actually, yeah, let me put it this way. Imagine that you have a transaction object. Transaction object has properties, right? For the next blocks. So you can initialize them with empty values and generate the hash for it. The previous block hash will be empty, but still it will generate hash and you will calculate nonce. But again, what is, in terms of business transaction in the very first block, doesn't matter. Nobody will use it. Nobody will read it. So Bitcoin is a reward for work. The more new Bitcoins are created as an incentive for miners. We want to bring more people to join our network. This is what will make our currency reliable. And you know, of course, remember this guy? Свадьба в Малиновке?
Старая Катерина.
Ты что, действительно, вот подпись и печать. Министр финансов и адъютант Папандопула из Одессы. На тебе 100 миллионов. Слушай, возьми все, я тебе еще нарисую.
This is Bitcoin. There are many different cryptocurrencies. Many companies are trying to release their own. For now, Bitcoin is probably #1. Even though there are some others, like Ethereum, for example. And the question is, what does the Bitcoin blockchain and Ireland have in common? Anybody knows? Yes? Perfect. They consume the same amount of energy. The Bitcoin network and Ireland. So you can imagine how much money it costs, or it burns actually. It burns to produce money. I mean, it's a different world, of course. Again, I will not go into detail, but why no one can easily change the blocks data? Say we have a blockchain of 1,000 blocks. Each block takes, currently, by the way, to mine a block in Bitcoin network, it takes 10 minutes. They do it on purpose. They don't want to make it too easy. And they constantly monitor the speed of solving this little problem. See, people are getting smart. They are buying these powerful machines. They are building farms. And if I don't know who manages this Bitcoin, if they will see that all of a sudden it's getting very easy to solve these problems, they increase the difficulty to keep the time for mining one block around 10 minutes. So once again, it's not a fast database, so to speak, but nobody wanted to be fast. They wanted to be reliable and specifically used for this immutable, trustworthy blocks. So each block takes 10 minutes to mine. Let's say somebody wants to change the data in the first block or maybe in another block. He or she or it, they need to mine all the blocks after, so the whole chain will look like legitimate, right? So if we have 10, if you have 1,000 blocks, each block is 10 minutes, so we need 10,000 minutes to recalculate hashes in the whole chain, right? Even if you will do this, you will need to announce, guys, this is my blockchain, but most of you will say, this is a lie. We have different hashes. And now, finally, I will show you a couple of pieces of code. By the way, this book that we are working on, it's myself and my colleague Anton. When we started writing a book on TypeScript, we decided we need to find some sample app to illustrate different syntax features of the language. And of course, we didn't want to do yet another to-do app. Tons of them are there, right? So we started to think, what do we pick? So we decided to pick blockchain. First of all, it's hot technology. And second, we can show different versions of the same little blockchain app, so people can learn TypeScript and also learn this technology. So this book that will be, actually, they released the first, Manning has the program called Me Up, unfinished book, but it's already up there, ebook. So we released like 175 pages today, actually, today. I pushed them, I said, I'm going to a conference, many people are there, and developers in Ukraine are really happy to buy books. So I said, I need to tell them. So second part of this book is different versions of blockchain. So I'll show you a couple examples. I put chapter 8 and chapter 9 from that book. The code samples are on GitHub, so if you want to just look at the code sample, even without buying the book, which would be wrong, then you can go there. So let me do this. This is chapter 9. Let me go to chapter 8. Couple of more things about TypeScript, since maybe you didn't work with it yet. Nice language, well supported by IDE, compile time language, optional support of types, superset of JavaScript. Why everybody likes TypeScript? When I say everybody, I mean it. The surveys on Stack Overflow year after year show that it's one of the most loved language, and lots of downloads, and people are slowly adopting it. Instead of writing JavaScript, they write in TypeScript. With Java developers also are happy. Classes, interfaces, generics, public, private, protected, all that is there. I mean, it's easy to learn for us. For us, I mean for Java developers. So IDE supports it really nicely. In this case, I'm using WebStorm, JetBrains product, right? If you have IntelliJ IDEA, you can keep using it. It supports it. Really nice and really easy. So what do you need to do? You need to write a program in TypeScript. Excellent help, autocomplete, all that is there. If you try to make a mistake, it'll help you. It'll tell you. And then you need to compile it into JavaScript, because browsers are not planning to run TypeScript. They will keep running JavaScript. So in this particular case, I have a compiler, TSC, TypeScript compiler. I can run it. Now, all this code that you see, this is TypeScript. It was compiled into JavaScript. In this case, I'm not going to detail, it's not important. It was configured that it'll go into the dist directory. So this is the JavaScript equivalent of these TypeScript codes. So now, if I want to, let's take a look at the first one. Really simple example. I want to generate I want to generate the Genesis block and a couple of more blocks. First of all, I have this class block with a constructor. In the TypeScript, you just have to use the word constructor. And if you use keywords such as read-only, public, private, protected, a compiler is smart enough to understand that you want these arguments to be property of the class. You know how we typically give some arguments to a constructor, and then we just reassign them to this dot something. All right, so my class block has 1, 2, 3, 4, 5 properties. So in the constructor, I immediately invoke calculate hash. Calculate hash is this method over here. So what do I do there? I just concatenate each and every property of this block. See, I calculated. And then I say create hash using SHA-256 and use update and use digest. So as an output, it'll produce me the hash value using the SHA-256 algorithm. That's the code. Now I have constructor where I mine the Genesis block, line 33, and I have another method, add block, which technically creates a new block. We pass the data, so again, it goes to the constructor and it'll mine the block with the data now. Every time I will invoke it, it will not be Genesis block anymore, but it'll calculate hash for the provided data. So at the bottom, starting from line 49, I actually invoke this code. I create new blockchain, line 50. Then I say mining block 1. By the way, when I do new blockchain, it'll automatically invoke mine and generate the Genesis block. Then I invoke a method add block to generate the first block. Then I invoke it again with a different text to generate the second one. Then I turn it into a string and print it. So this is what I see on the console. See that? So it generated all that for me. So this is an output. Actually, no. I didn't even run it, sorry. I'm lying. I did it before the presentation. Let me do clear. And then I will do node. It's a runtime engine, right? I'm saying in the directory dist, I have a compiled code called BC101. .js, you don't have to specify. See that? It generated for me really quickly the whole blockchain. But hashes are not that we want. See, hashes don't start with zeros. The second little sample in the same project that I have is called BC101, proof of work. And this is where we apply brute force to find, to loop, to iterate through this process to find the one that, in this case, see, I keep incrementing this nonce until the generated hash starts with 5 zeros in this case, right? So once again, very, very simple code. I have this class block to represent the block with some properties. And by the way, nonce is one of them. See this? Nonce. Again, this is like a digital signature. This is that rubber sole that I was talking about. I have a method calculate hash right there. This method can calculate one hash. But if I will keep calling it multiple times with different nonces, at some point, hopefully, it'll give me what I need. So mine, method mine. I'm doing mining, right? And this method returns this structure. So what I do, again, similar to what I explained on the slides, I do a do-while loop, keep generating, incrementing nonce until it is 5 zeros. And then I push it into the chain. Chain is like an array. I store the chain. So very similar to the previous one. Starting from line 59, I create a new instance of the blockchain with the Genesis block, and then I do mining of 2 blocks. Let me do it again. I will clean this terminal window. And I want to introduce this BC 101, proof of work. It will be, see, it's still too fast. But 5 zeros. If I would change it to 6, it would be substantially slower. See, Genesis blocks, it generated, you can compare, it calculated. See, in this case, I can see that it had to run this loop 225,000 times to find this value, right? So hash is this. What else is there? Previous hash is 0. It's a Genesis block. Now the next block, look at this. Hash is 0, 0, 0, and then 582. This is this block's hash, and the previous hash is this. Look at this, BCA 3529. BCA 3529. It points properly to the previous hash. Once again, the next block. The next block is, again, this is its own hash, and the previous hash is 582 something. Yes, 582 something. We are linking. So these are these two examples. Now I will show you another one in chapter 9. It's another example which uses the web page as a front end. So the user can enter transaction 1 or 2 or 3 or 4, and then hit the button and it'll generate the blockchain. But again, this guy is using the client UI. I didn't use any framework over here, just a simple JavaScript, HTML, and CSS. And let's try to see what we have there. This little couple of functions that calculate. Sorry, it's JavaScript. I don't want to look at it. It's calculate transactions. In this case, transaction is represented as an object. See, it's an interface. TypeScript supports interfaces. And we can generate one or more of these interfaces. In this case, like line 16, I have a bunch of them. Remember how I said each of us has a piece of paper and we write like 10 transactions. Whenever we have 10, we mine the block. Then again, I do the same concatenations and nonces and everything. I will not go into detail. We have like 7 minutes left, but let's run this example. To run this example, you need to do npm start to start this little web server that comes with the project. It's called serve. It's a web app, so we need to start the web server. And it says that it started on localhost port 5000. Let me go to browser, and I will go to this localhost 5000 dist. This is where my JavaScript, compiled JavaScript is sitting. And you will see this simple, very simple basic UI. Initially, see it says initializing the blockchain. It was mining the very first blockchain. And at the bottom, it showed me that blockchain. Down there, it tells me what's the status of my blockchain now. Right now, it has only one Genesis block, nothing else. And then I will start adding transactions. For example, this is a help. For example, Joe, Mary, what, 100, for example, dollars. Transfer money. Technically, I'm adding this to a pending transaction. Like again, that piece of paper has one record now. I keep adding more. So far, I don't generate any blocks because I want to generate block for many of them. By the way, in Bitcoin blocks, I believe they have one block per 256 transactions or something like this. So creating a block is expensive operation, so they don't want to create for every move a new block. So Alex, recipient Joe, 200 for example, transfer money. So I keep accumulating in the middle pending transactions. Let's say I allow you to have only two of them. When I hit confirm transactions, it'll start creating block for me. So it starts doing mining. It keeps working. And when it's done, I see down there, see block number 1. Pending transactions are cleared out. And I can keep doing this again and again and again. So this is how I build the blockchain. And what is important, if all of us would be members of the same blockchain, you would get exactly the same thing. I would announce, I found this nonce, see previous hash, this hash, and so on, and you would be replicating this block because I was the first who mined it. Or maybe next time you will be the first. So this is basically what I wanted to tell you. These are some links. My blog is yakovfain.com. The book, if anybody wants to get it, that's the URL at Manning. Again, this book is, so far it's a Me App program, 175 pages, and GitHub for the examples. And now I'm ready to take some questions. Yes, I don't know how you want to do this. If you can speak loudly. Yes, please.
Hello, thank you for this very interesting information. So how can I transfer, let's say, $100 from Kyiv to New York, and how much will it cost me? So this system is to replace, let's say, Western Union or MoneyGram or some other types of transferring. So can I use this blockchain technology or a particular provider, Bitcoin, to transfer actual money from here to, let's say, to other person in?
You can, if let's say you want to send me $100, but you want to use this blockchain, the Bitcoin technology. Okay, the question is, do you have Bitcoins? Yes, no, I don't know. Do I have Bitcoins? Yes, no. If I am the member of Bitcoin network and you are the member of Bitcoin network, what you can do, you can buy, let's say you want to send me 1 Bitcoin. So you can take an equivalent amount of dollars, buy a Bitcoin, and your account will state that you have a Bitcoin. Then you will do transfer, block will be created, and then I can get it. I can either keep it in the blockchain, or I can, again, reverse it and get the money out of it. I already saw ATMs, these cash machines on the streets that give you Bitcoins. Next.
Меня слышно, да? Добрый вечер. Если можно, я на русском задам, чтобы правильно сформулировать. Меня интересует такой вопрос. Я понимаю, что этого сегодня не было, но используется, ну, как бы криптография на эллиптических кривых, как я помню, здесь используют в основном. Мне было интересно, как-то я не могу найти информации, используется ну, у Виерштрассе уравнение y квадрат, x куб, xb, ну, вот это уравнение. Кривая, по-моему, SEC P256K1 называется. Почему в основном используют только ее? Плазма, эфир, они все почему-то только это используют.
Они используют, sorry, I need to speak English. The question is, why do they use specific math formulas? They are trying to find the more secure hash generation. And what I showed you, I said that SHA-256 is great. But it's not exactly great. They also, on top of that, they use public and private keys. So they are trying to find the most secure formula to generate hashes. Probably that's why. I don't see any other reasoning.
During your presentation, you implied a proof of work when speaking about consensus. But as of now, there are lots of other algorithms. What are your thoughts about them, and specifically proof of stake?
I don't know about proof of stake. My presentation was about principles of blockchain. There are more than 50 probably super popular currencies already. They have something specific. Some people say blockchain should be open. Some people say, no, we want to have it private, so it's not exactly the classical blockchain. Some people, blockchains add something specific. For example, Ethereum blockchain adds so-called smart contracts. I was talking about storing data, storing blocks inside the blockchain, but smart contract is a program that is stored inside the blockchain. It's also immutable. You cannot change it. If you have a bug, you have to create a new one. So, because, for example, if I'm buying a real estate from you, there are some steps, and I have to go through them. Each step will trigger execution of certain smart contract, and in the end, the house is mine if I was buying it. So. I cannot answer your particular question, but I'm saying is there are many different people, different companies who are trying to apply these technologies in different ways.
So basically we need to sum up, and you can address the questions personally, and before getting